Hey guys, today we're going to be taking a look at how to solve this problem. It is an optimization problem. A farmer has 100 meters of fencing material to enclose a rectangular area for animals. One side of the rectangle will be formed by a barn wall, so no fencing is needed on that side. What dimensions will maximize the enclosed area? So first, let's draw a diagram. So I see that the question talks something about a wall. Let's assume this is the wall, and there's a rectangular area. And let's give this dimensions. So let me redraw that. This is X and this is Y. And I also see that they say a farmer has 100 meters of fencing material. This implicitly says that this is the perimeter. So in order to find the perimeter, we get do Y plus X equals 100. And this is why we do not count this, because it said no fencing is needed on the side of the barn wall. So there is that. Now, this is going to help us to find the area, but we actually need an area equation because that's what we're trying to maximize. Area equation of a rectangle is simply xy, length times width. And in this case, we know whenever it talks about maximum, we know we have to apply differentiation. But in this case, I want to get this equation in terms of one variable. That way, it's really easy to differentiate. So in that case, we already have this equation. I'm going to find x from this equation. So if I find x from this equation, I get x is equal to 100 minus 2y. And replacing it in equation number 2, I get a is equal to 100 minus 2y times y. Let's simplify this. We get 100y minus 2y squared. And now we can differentiate it. So we get dA over dy, I'm differentiating with respect to y, we get 100 minus 4y. And in order to find the maximum value, we have to find the critical points first. And we can only do that by setting the first derivative equal to 0. So we set that equal to 0, we find y is equal to 25. We don't know if this is a maximum value or a minimum value, because a critical point can be either a maximum or a minimum. So we have to double check that. And we do that by using the sign test. So by using the sign test, we know our critical point is 25. We have plotted that. Now we have to pick a number to the right of 25 and to the left of 25 and plot the signs. So if we pick a number to the right of 25, such as 30, and we replace it in the derivative function, which is this function right over here, we get a negative value. And to the left of 25, we get a positive value. So this indeed is a maximum value, and that is exactly what we're trying to find. We have to maximize the enclosed area. So in this case, we get y is equal to 25, and x, we just replace it in here. We get x then is equal to 50.